Okay, so let's now work on the ability to sort of check out more than one prediction at a time. So we're gonna do a number of them. We're gonna do a number of rows. We're gonna do a number of columns. And we're gonna do a number of images, which is going to be equal to the number of rows times the number of columns. Okay. PLT dot figures fig size. We're going to set up a bunch of different figures here. And we want the fig size to be 10 times the number of columns. Because we basically want the fig size to be, we want each one of these to sort of be 10 by 5. So we need the overarching fig size to be 10 times the number of columns and 5 times the number of rows. All right, and now well, actually, we should give this another name. Let's call this let's call this multiplier. Okay, for I in range num images. What do we want to do? We want to make a subplot, PLT subplot. That's going to be num rows by 2 times num columns, because it's going to have 2 pieces to it in each one of the rows. And it's going to be 2 times I plus 1. Okay, and then we're going to do plot pred prediction probabilities is going to equal predictions. You can probably figure out most of this by now, right? Labels is going to equal val labels. Images is going to equal val images. And then n in this case is going to be I plus the multi. I guess that's not really what a multiplier is, right? What would that be? Offset, maybe? Offset, maybe, is a better word. Offset plus offset. Just kind of so we can look at different groups of images and predictions and results and things. Okay. So that's plot pred. And then our second subplot, PLT dot subplot. Again, num rows 2 times num columns 2 times I plus 2 in this case. And this is going to be the confidence of the prediction. Plot pred conf, passing it prediction probabilities, which are going to be our predictions. Oh, comma. This also takes labels, which are going to equal the val labels. And then it's also going to take an n value, in this case, n equals I plus offset. Okay. That's it for the for loop. So let's go back out here. Let's say PLT dot. We're going to do a tight layout with a horizontal padding equal to 1.0. And we're going to do plt.show to kind of show our plot. So, yep, I made a mistake. All right, let's see. PLT figure, not figures. Okay. Oh, and there we go. And now you'll kind of see what results we have. So, for instance, it thought this was a flat-coated retriever. It was correct. Thought this was a Samoa. It was correct. Thought this was a miniature Schnauzer. It was not, in fact, but I can see why it would get that confusion, right? Spaniel, Springer Spaniel, Irish Wolfhound, when in fact it's a Scottish Deerhound, okay? But now we can kind of see a bunch of results all together, and then if we want, we can offset it differently each time, and we can see a different set, right? Like, that's a really hard picture to figure out. This is a classic, right? Because it's got kind of this pretend dog on top and this dog underneath. And notice something here, that we aren't actually seeing enough results in either one of these to see what the correct guess was. So if that's the case, if we get to this point where we're not seeing enough results, remember we kind of built this into our function up here. So if we go back up here and we look, we have a comparison number equal to 5 in our predconf. So we could do in our predconf here, we could add something that says comparison number and raise it up to say 10. Okay. And run that again and see now, are we seeing the ones? Yeah, so this is actually a Border Collie. Here it is at number 6. This is actually a Yorkshire Terrier. Here it is at number 6, I think, again. This one I got right. This one I got right. This one I got right. And those are ones it's very confident about. This one, okay, it thought it was maybe a miniature poodle when it was, in fact, a standard poodle. Okay, well, you know. Splitting hairs a little bit there. That's probably a hard one to tell. And we just don't have enough pictures of standard poodles in this 1,000 image set. So that's okay. But that's a nice, easy way. Let's do another set of these. Let's go 5. Just see what we get. Yeah, we've seen some of these before, right? Bentley and Terrier did well. St. Bernard, Old English Sheepdog, Collie. That's hard, right? It thought Collie. It was a Border Collie. Okay, you know. All right, we saw this one already. And let's go. We did 1,000 of these, so let's go a little bit higher. Let's look at like 100 as our offset, right? And it just lets us look at different groups of them. Bernese Mountain Dogs, adorable. Also thought it was a Bernese Mountain Dog. It wasn't, okay? But you can see, all right, yeah, I can see the coloring's a big part of what it's guessing at, right? Thought it was one kind of terrier, actually ended up being another kind of terrier. Okay, this is hard, right? There's 2 in that picture. So what kind of analysis is it doing there? Got the Rhodesian Ridgeback. Okay, good. So now that we've trained a model and maybe we're happy with it, maybe we're not, let's just go remind ourselves how we save a model. We're going to write 2 functions to save the model and to retrieve the model. I know some of you have already done this, but worth doing again. And in this case, we're actually going to write, I don't know if we've done the writing of functions to do this before, so let's go ahead through that. So first of all, we want a model directory. So we're going to set our model directory. It's going to be equal to os.path.join. We're going to give it I think we just do, let me check up my code here. I always forget whether or not we put the / before or after, but we can find that out by looking up at where we're drawing in our data from. Where are we? Here we go. Okay, no, we don't need one. So we'll just say that our model directory is going to be models. That's actually fine. And we're going to say that our date time dot Do I need to import date time? I might actually need to import date time to get that to work. I don't think we need to install anything, because I think it's part of the standard library. But I may have needed to import date time. Yeah, let's go ahead and import date time. Before we run this, we'll just do import date time. Datetime dot import datetime. We're going to do datetime. See, now we're getting the autocomplete, which is nice. By the way, I make that pop up by hitting tab, if you don't remember. We want to grab the datetime that it is right now. And then we're going to do str, which means string of time format. We're going to give the format for it, and we're going to do %y, which is year, %month, which is month, %d, which is day, dash %hour, %minute, %seconds. And that is going to give us our model directory. Then model path is equal to model directory plus a dash plus the suffix plus .h5, and that's the saving format for the model. We'll go ahead and say print saving model 2, and we'll just pass in the model path so we have some information being sent back to our user. Perfect. And then we'll do model dot save, passing in the model path, and we will return the model path. Let's make sure there's no errors there. Okay, that looks good. And now let's go ahead and say model path is equal to save model, passing in the model. Okay, let's see what I did wrong. OS is not defined. I swear I imported OS, but maybe I didn't. So let's go ahead and import OS. Cannot concatenate string not none type. I guess we should have to give it a suffix. All right, let's pass a suffix. Let's say, let's do model equals model and suffix equals, you know, this is like 1,000 images. That's probably sufficient for now. Okay, good. Okay, doesn't seem like that's a problem. Seems like that worked. So now let's do our load model function. Okay. And basically we just want a model path to load from. And we can say print, it's F string, which is loading saved model from model path, right? Good. Give a little information to our user, and we'll just say model is equal to, we'll use TensorFlow library. We're going to use Keras. We're going to use the load model function, passing it a model path. And then we're going to say custom objects, I think. Right? I'm surprised this isn't finishing. Keras layer. Hub.Keras layer. Okay, let's see if that works. And then we'll just return model. Oh, I never finished the string. That's a problem. Could be part of my issue here. Good, that worked. And then we'll say model equals load model, passing it the model path. Okay, we have an issue. Let's see. Oh, I spelled load model wrong. Okay, what else did I do? Huh. It says it has nothing called load model. Let's try this again then. It's there. Weird. Attribute load model. We know it has no attribute load model. Let's try this again. So let's do Keras dot. Interesting. Oh, Keras dot. I know why. It's actually not in just the Keras. It's in the models dot load model. There we go. Now we're getting it. I know we passed it a model path. That's why we weren't getting the autocomplete on this. That made me worried before. Okay. Keras layer hub dot. Yeah, this looks right now. I think this is supposed to be. There we go. It's supposed to be the class name, not the object. Okay, good. That makes me feel better. Let's see now. Error when deserializing class Keras layer using config. Did I use the dot? Did I use the number 4 or the number 5 when I did this? Which HTTPS did I use? I used the 4. So I feel like that should be right. Oh no, I did use the 5. All right, hold on. Let's use the 4 again. Oh, interesting. Still trying to do it with the 4. Oh yeah, it is the 4 now. If I switch it back to the 5. That works. Okay, interesting. We'll have to look at going to go through this again quickly. It probably won't take that much time. But I want to see when I build my model and everything if... But that means I did do it with the 5, which makes sense why this might be having a problem. Okay. Well, you go through trying this on your own and see how you do loading it in and out. We might not actually need this custom object piece. I'm wondering if we can do it using just this. Well, now that won't run until all this is done running, until it's done training and everything. Okay, well, I'm not going to make you watch this train this whole time. Good job. Make sure you get those functions and try loading in and out the model that we saved and load the model back in. And then we'll go from there.